second.
That is precisely what
This
you're
is the
saying.
measure of
Frequency.
frequency.
Yeah.
This is the measure of frequency.
Absolutely.
Okay, fantastic. So, well, let's take that slowly. Let's take it slowly. Hertz means number of circle per second. It's an international coinage to describe that. And when you now put mega is a million, and that gives you the actuality of what you are talking about. Okay.
Certainly.
Do I get it, Dr. Adamu?
Very correct. Very correct.
Okay, so the G and the M, giga and mega. We've talked of the mega. How about the giga?
Now,
the gigahertz.
When you talk of gigahertz, giga in physics, it means 10 to the power of 9. So you're actually talking about billion.
Okay. 10 to power of 9, it's 1 billion.
Exactly.
1 billion. Mega, it's 1 million.
1 million.
Giga is 1 billion. So giga is also a number of cycles per second. So,
Exactly.
Yeah, okay.
Everything has its number of cycles per second. So for example, if you said 3.5 gigahertz, what you are saying is actually 3.5 billion hertz. Billion hertz. That's basically what you're saying.
Fantastic.
Yeah.
Also, giga is higher.
Giga is
mega,
higher.
Mega is lower.
It's a
Okay,
factor
so
of
which services do you find megahertz and gigahertz? What I mean, television for example, what are we using on television? And then is it specifically tied to a service, or they can be versatile and robust?
Usually, all those all those frequencies, they're actually divided into different bands.
Okay.
So it depends on which bands you're actually using. For television services, you use a different band.
Okay.
For telecommunications, they use a different band.
Okay.
And for the user, of course, if we talk of relation to the internet connectivity, users usually, they don't go into the detail of the hertz, megahertz, or gigahertz. What the users are more familiar with is actually bit or megabit. That is basically what they are. Mbps. That is what
that's for the user.
Exactly.
Okay.
So now the issue probably which will interest the user is that what is the relation between a hertz and a bit, or a megahertz and a megabit?
Okay.
So of course, the user knows that if he's going to get 10 Mbps, he is getting a connection that has a measure of 10 Mbps. But now, how does that translate into megahertz? Now, because for an operator, the megabit is not the issue, but actually what he has at the megahertz. In fact, the megahertz is the one that will determine what kind of megabit he's going to give. So usually the relation is determined by what is called the modulation technique. So the modulation technique, it's all about, I have a unit of frequency, let's say a 1 hertz. Then that is the unit of frequency. Then I have the unit of data, which is bit. Now, how many bits can I be able to squeeze into 1 hertz?
Okay.
That is the modulation. So it's the function of modulation to determine that. If I'm able to squeeze in only 1 bit into 1 hertz, then my ratio is 1:1. But if I'm able to squeeze in 2 bits into 1 hertz, then I am now utilizing my spectrum more efficiently. Now, if I have modulation technique that will actually squeeze in 3 bits into 1 hertz, so you can see, the more I get a better modulation technique, the more I utilize the efficiency of my spectrum.
Also spectrum, yeah. Okay,
Exactly.
so that's very vital. How does that relate to quality of service at the end of the day? Let's bring it down to the bottom line now.
Yeah, actually, usually the user would have a good experience in so far, because now we are talking of air. In so far the atmospheric condition is actually okay, he will get a very good service. Of course, in a situation whereby the weather is bad, then it will affect that modulation technique.
Okay.
So usually what happens is that instead of the user not to be able to get a service, there is what is called adaptive modulation technique. So if, for example, I am actually enjoying a service with a modulation technique that is squeezing in, let's say, 3 bits in 1 hertz.
In 1 hertz.
Now,
weather can make it not for you to be able to have all the three
Exactly.
into
So,
that.
so
Okay.
if that one happened, before what is happened is that it will just cut me off completely.
Completely, okay.
But today with the new technology, what
Okay.
you do is, okay, fine. Can I be able to communicate with him on 2? If yes, then it will scale down to 2.
Okay.
Then, if on the other hand it cannot, then it will come down to 1, which is actually the basic.
Okay.
Now,
So,
now
so
what,
as it comes down, the services drop, right?
as it comes down, what will happen is that the service is not affected, but if you have many people actually trying to communicate at the same time,
Yeah.
like for example, if my connectivity, let's say, is 3 meg, and I am actually enjoying the services at the maximum spectral efficiency, which is actually squeezing in 3 bits
Into
in 1
1
hertz.
hertz, yeah.
Then by the time this service actually dropped
Drop
to 1
to
bit,
to 1
then
bit.
what would happen is that it's as good as trying to squeeze in 3 Mbps into a pipe that can only take 1 Mbps.
Okay.
So you can see what would happen is
congestion.
that there's going to be congestion, there's going to be degradation of service, and so on. So that is really